the slack, couple man run around like they hate in the gaff. Please stop talking that trash, cause the vibes and the fun all the way to the back. Is that light work with the bass on the track, on my face to the back like I'm taking a slap. I need a drink but it's straight from the tap, and I'm hating the slack, couple man run around like they hate in the gaff. Please stop talking that trash, cause the vibes and the fun all the way to the back.
When it be When I'm lonely in the dark, I know you are with me. Yeah. Don't you see that I need you so much? Don't you see that I love you so much? Oh na 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 na, oh na 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 na, darling, I need your love. Oh na 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 na, oh na 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 na, darling, I need your love. When I'm lonely in the dark, I know you are with me. Yeah. Don't you see that I need you so much? Don't you see that I love you so much? Oh na 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 na, oh na 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 na, darling, I need your love.
Hello, we are back for more binary exploitation practice, more ponables practice. And let me switch over to my monitor. Brief bit of information before we start. There's a CTF going on this weekend called Hackasat. It's by the United States Air Force. So yeah, if you are interested in playing a bunch of CTF challenges, give it a shot. Or I guess this is the qualifier for it, and there's the main event is taking place simultaneously with Virtual DEF CON. So similar, I guess, to DEF CON qualifiers. My experience, I checked it out a little bit before the stream. The challenges that are open right now. My what I saw was like there's a lot of math based kind of stuff, calculating, I don't know, rotations and stuff. Like it's all kind of beyond me. If you've watched any of these previous streams, you might see that I don't it's not very uncommon for me to struggle with basic arithmetic kind of stuff, basic algebra even, or basic algebra and even basic arithmetic, I guess. So yeah, calculating, I don't know what angular values to give to rotate something related to a quaternion, all that is like not is beyond me. So I'll keep monitoring it to see if there's any kind of ponables challenges that show up. The closest I saw was probably more of a reversing challenge. There were two that I saw that might have been reversing challenges. The first one, all the source code was MATLAB, and then as I dug into it more, I think it really was just a math kind of challenge and figure out how to provide the right, read the outputs that it gives you in terms of these 3 coordinate angles or 4 coordinate angles, I guess. Not coordinates, but like, I don't know, the angles. And that's representing a rotation, and then you give it a better like a adjustment, I guess, and if you adjust it over time to exactly the right area or out of bounds of something, it'll print the flag for you. So That one, maybe a little bit of reversing just to see what the program is trying to do math-wise, but then you still got to do a lot of math that I don't think I would be able to learn and get decent enough at in a weekend in order to accomplish it. And then the other one was like I don't have the pages up anymore, but it seemed to be some kind of program for a command and control system for satellite telemetry, and I think they added a special command in there that allows you to print out the flag. So basically you gotta like reverse the source code of the system for doing that communication and figure out how to send it the commands that you need to do. Yeah, I took a look at it for a little while and then kind of got, I don't know, dismayed or bored or whatever. Not super interested in what I've seen so far. But they must have opened up, maybe they opened up a couple more, because last time I checked, PPP didn't have this many points. They show me they opened up another one, so maybe this is like a pwnable that I could work on. I won't work on it on stream, obviously, not while the thing's going on. So yeah, right, they just unlocked that like 6 minutes ago, and I don't think anybody's solved that actually. Oh, and they opened this one as well. These ones all seem to be very math heavy. So I don't know. I'll keep a look at it. If that's sort of your thing, then definitely check this out. There's still a lot of challenges that'll be unlocked over the period of they've still got a day and a half or something like that, more than a day and a half left on the time for it. So if you go to hackasat.com, if you happen to be watching this on the weekend of the 23rd and 24th, you can still get in there and play it. Okay, but I am going to continue to work on pwnables on the stream. So we finished up with the format strings section. I woke up early this morning and had some weird dazed thought of like creating a program to kind of automate a lot of the work that was done to solve the last of the format string challenges. And basically, if you give it the right parameters and then you say write this value to this address and write that value to that address, it'll work out through some fuzzing and all that what the input string with the format stuff and the addresses in it should be. And so I think that would be kind of a neat challenge to work on. Not a challenge in the CTF sense, but like just a fun little program to write up. I won't do it on this stream, but maybe I'll get started on it off stream and then review it on stream if it comes together into anything. Because I think for relatively simple format string pwnables challenges, they do sort of reduce down to overwrite a particular memory address or set of memory addresses, and then it's just the work of like figuring out how to generate the right format string to accomplish that. And assuming, let's say, that you simplify it and say no challenges that require you to both leak a thing and then later use that leaked data in the next round of input or something. If you can just work out what addresses you need to change, then it should be possible to automatically kind of generate the right string for that. So might be a fun script for working on CTFs that are live so that you can quickly get through them. But we have now moved past the format string challenges and we're on the array indexing challenges. And there are 4 of them in this category, so we'll just see how far we can get on the first one. This first one is Seesaw 2018 Double Trouble Pwn. I guess 200 points is the 200 there. And it's named The Floating, I guess. I mean, Double Trouble, the floating, like probably we're talking about floating point values, maybe double in size of the actual values. I don't know, we'll find out. I have copied the file in, so we'll look at it. It's 32-bit ELF, dynamically linked, not stripped. Okay, and no NX bit, so maybe we could shellcode stuff. Although with array indexing, certainly it's possible. Yeah, maybe we put our shellcode in the array and then the index, like going out of bounds allows us to overwrite the return pointer and jump to our shellcode. No PIE, so that's handy. Although I think we'll have to see. We might have to leak a stack address or something. I don't know. But we could, if we have arbitrary write locations, from having like the array indexing vulnerability, then we could write our code to somewhere in fixed address space writable executable memory and just jump to that instead and not have to worry about the stack actually. So if we run the program, it leaks us an address, I guess. Let's double check that. Yeah. Okay, so it first prompts us for how many entries I guess we want to give, and then prompts us for each of those entries, prints out the entries, prints out some basic calculations over that, the sum of them, the max of them, the min, sorts them. Interesting. Okay. And then it picks its favorite one, which I don't know, maybe it's just random. Okay. Interesting. So we open it up in GDB. You can look at main. It's going to go to the game function, to VMM. And so we have read write execute on a section that is what is 1000 hex? 4 kilobytes, I guess, maybe one page. So we could write stuff into there potentially and jump to it, but what is the address that it is printed out earlier? FFF, like probably, yeah, so it's printing us a stack address in case we want to write to the stack. I mean, maybe we have to write to the stack. Maybe the array indexing can go out of bounds, but not so much that you could write to this page or that mapped in section. So, okay. Then, what does game look like? I'm gonna check this out in Radar, I think. yeah. All right. So we print out. So these are our references to the format, the string formats, I guess. Which is interesting. It says it is not PIE, but we're using the get PC thunk, which is the sort of thing that you do when your code is position independent, I'm pretty sure. Because then these are instruction address relative to like this instruction address, maybe. Okay. And then we put the address of 210 on the local variable at 210 hex into EAX. And if I had to guess, this is going to be have, maybe that's percent. Percent D colon percent, no, okay, it's different. Let's see. Well, if how long is that -1 FEC? This is F0. Then it should just be for interesting. So I think that this is the prompt for how long. And then we scan F, your choice. So I would have thought this address, but oh, it's going to be at 10, right? 10. Yeah, %P. Okay. It just was too short to be caught as a string by radar. So we are printed out the address of this 210, which is probably the buffer that we can add to. So 210. Maybe there's a way to do it in. Do that. 132 maybe. 132 entries. Although it's really -1 from that, I guess. Or sorry, it's -3. Is that accurate? Yeah. So maybe we can do 129 entries before we start overflowing into whatever this stuff is. There is a stack canary, which is interesting. I don't see it being set up here. Oh, there it is. Okay. So if we overflow, if we were to do something, do we have to leak the canary? I'll have to figure out, but yeah, so if we say okay, I guess because we didn't yeah, we're just getting sort of random values in there because we aren't clearing out that buffer at all. Okay, so then if we say print 130. And then, what do we want? Just 0 for each of them, I guess. Times 130. What was that? Oh, but then it will print us. Okay. Oh, okay. Get char. What? Wonder if it is. Nope. Because we are like, I guess scanf is not ending on the new line. Might be taking in a much longer buffer. Haven't really bothered to look at. But you'd think scanf would be what it's using to do the conversion to a number. So oh, I see. We just can't do more than 64, I guess. Otherwise it goes into that mode. Is that right? Let's say nope. Oh, Jesus Christ. Okay. Interesting that is taking nothing for each of those and counting it as 0, I guess. But if we do 65, okay. Do find it, I don't know, like, why it is printing out system from this stuff. I guess that is the address of system relative to the start of this buffer or whatever. Maybe the address of the system GOT entry. So, okay. Don't really care to figure that out. So we can provide 64 entries. So not enough unless they're all 8-byte values, which, what does it look like? Then we can do 64. Okay, so that's enough to fill the buffer but not overflow it. So come into the loop and this is 218. It's our index. Okay. I see. So we malloc what? 100 bytes. Printf. Okay, we get 100 bytes for the space for the string for input before calling A2F on it, rather than do scanf, I guess. To call fgets and we only read 100 bytes, that's probably fine. I mean, there's the potential that it isn't accounting for a null byte or something, but I'm not gonna, since this isn't a buffer overflow challenge, I'm not going to look for that as the solution right now. I guess I can like it reads one less than size and make sure to null terminate it. Okay. Yeah. Okay. Then pass that to A2F and store it at it doesn't specify an operand that is actually being stored. It's gonna. So let's double check how that command works. In the st0 register, and it also pops the register stack. So yeah, I don't really understand. I've never looked at much in the floating point, like classic floating point, not the SIMD stuff, but I haven't looked at the SIMD stuff either, really. So I guess there is a stack of floating point registers. I don't know if that is literally stored on the stack or what. I'm guessing no, because we're already fixing up the stack size after calling ATF. So we're storing at EBP. Where are we getting EBP? Just probably 210. Oh, sorry. Right, it's, yeah, I don't know. Where are we getting EBP? I'm not thinking very clearly. So EBP plus minus 210, start of our buffer, and then 8 times whatever index we're at. Okay. And then we come back around and we increment ESI somewhere. Where does 218 get incremented? Oh, I see. So 218 is just the pointer to, is that right? No. I see. This is the increment. It's just doing the LEA. Yeah, I should have. Okay. next one. Okay. We don't free the memory that we are allocating. We're tracking our input strings. Weird. I don't know if that is an intentional issue or not. So thus far, I don't see anywhere that like we are providing an array index to get an arbitrary right location, which I thought was sort of what you're supposed to do. I think if we put in a negative number, well, it didn't take it as, okay, it just sort of considers it 0, I guess. Oh, the get char is probably just to get the new line out of the way. Okay. Then shouldn't this be doing, like, is this not a, how do I put it? Wait. Oh yeah, okay. Is the comparison not a unsigned comparison? Okay, so we're going to take whatever that is and subtract 40 hex from it. But this would be, you know, FFF whatever if we do -1. So I don't understand why scanf. Let's look at that. So that is FEC. And then, or sorry, that was FF0. So 15 more than that, just %D. Well, it only seems to, I mean, it seems to treat it like I had put in 0 if I put in a negative number. So I don't think that is the approach. Maybe there is something that goes wrong with printing like the results at the end, calculating all that stuff. But yeah, it's like let's see how we are controlling the index of the array. So let's look at sum array, for example, to start with. Sum array is getting, oh yeah, okay. First parameter is the length. Right, okay. Then the sum stuff, okay. I'm gonna have to go through all these. there's so many arguments to find an array has two fixed floating point values, I guess. Okay. Seems to have 5 parameters, 6 parameters. Oh, there's one C. Where's that using argc? Damn it. Okay. So right here, it's putting the length of the, or like the number of entries that we gave into local 4. And then the next thing it's doing is it's getting that length again and it's adding it to local 4. So it's doubling the length. And then now I'm trying to figure out where it is storing something to the local 4 address. It's doing it up here. Is it storing something in arg8? Yeah, I guess it's doing it here. Okay, that seems weird. Hmm. I don't know why it's doing it that way, but it doesn't seem like it is necessarily broken. Yeah. So, I mean, we are just searching through, and if we get a number that is between the two floating point parameters that were given, so if it is maybe less than this one and greater than this one, then we come down this path and EAX ends up being the index of that particular number. Or it's greater than this one and less than that one. I don't know. I'd have to understand a little bit more about the floating point stack and how fcompi works, I guess. Yeah, otherwise I don't see anything in here. It's just, it's not what I would have thought for how to calculate this stuff. In that the numbers it's using are like, it starts at the however many entries. So if we give 10 entries, then it starts at 10 and it counts from 10 to 20. And then right before it returns, if it finds a value that it likes at 5, at the 5th entry or something, or let's say the 6th entry, then it would return 6 because it's going to do 20 minus 14 or something. I don't know what I'm saying, but it's like they subtract out the fact that they have doubled the number. So I don't see anything there. I genuinely don't see any way to get this to write to memory that it shouldn't, or even read from memory that it shouldn't thus far. Maybe it's under the sorting. So let's see if this was what is that, 1FF0? Then this address minus or let's just do this actually. Okay, minus 1E03. Can we do, I guess we can do the whole thing. That'll be that address. And then we print a floating point value. You can print a QR code. Print formatted data. Maybe. Should look into that. And we can print a stereogram. I don't know what value that has for me. Let's see. Okay. I want double. To not have that. Cool. Okay. I could have sworn I saw something in the overfloat challenge, their walkthrough, that was using UF. So, oh, they just had to define it themselves. Never mind. I missed that bit, and I thought Pwn Tools had its own thing. So if we say that you have 64, unpack these bytes, be import struct. Remember what the right syntax is for a double, just D. Okay. It'll probably be little Indian is the other way. Yeah. Okay. So we can no, I want let's just do one of these earlier ones, like print bytes P8 maybe. P8, and then I guess that, or do I say at? Where's my goddamn weird. So we do this one, or try to interpret the. Okay. That looks, yeah. So then. Oh yeah, just %p/n, I guess. So then am I wrong about the address? It's gonna be where's the find? 1 minus 1e, so it's plus whatever that difference is. So maybe we can do it this way. So all F's, interesting. And then C8, so 8 beyond that. Why is, that seems weird. I guess, yeah, okay. B? No, I am definitely in the wrong area. Oh, I have subtracted the wrong amount. There we go. Okay. So a number between -10 and -100 is what it likes. Let's try it. Okay. Sure. Yeah. Is it? Oh, oops. So why does it take the -50 instead of the first one that fits? Right, like, sorry. Okay. Oh, maybe I was taking the -10 because it was, no, it wasn't even the first value. Okay. So, am I just thinking about this incorrectly? Like, okay, in theory, if we could get find array to give us a number, give us back an index that isn't within that range, then, you know, this would load a float that is out of bounds, and we would leak some information. I don't have a way to do anything with that leaked information before the program quits, because it's just going to print out some stuff and then and exit. And that's all based on the idea that find array could return a value outside of the array, an indexed number that's, out of bounds, but it didn't look like it could. I need to review it harder, but sorry. Again, the receiving the actual sequence of number inputs does not appear to be resulting in any kind of out of bounds access. Do so I find it a little bit interesting that we have a max and a min even when the number is 0. Well, I guess, okay, that's because basically we pull out the first entry from the array, even if nothing has been written to it. When we get to this comparison, since EAX is going to be 0, because that's the size that we entered, it's going to be not less than the 0 that we just put in there. So then we come to the return and we load up the float that we just saved. Okay. Oops. And presumably the same thing for min. Don't think that helps us at all, other than, I mean, in theory, we could maybe calculate what those 8 bytes are. But again, this is all data leaks. And I don't know what to do in this challenge if local 8. wow, I can't believe I'm like really this. There's a helpers function. Interesting. If some max min find sort and print. Okay. What does helpers do? Where does it get called from? Doesn't seem like it gets called from anywhere. What is the string there? One F 5B. And what are we reading in a string of length 10 into buffer at 24 hex? And then doing what with it? We aren't checking the stack canary that we set up. It's interesting. But I mean, it's not like we could write even to the end of that if we're only reading in 10 characters. So what? Oh, why have I completely lost colors? Yeah, I don't know. This is frustrating to just not even have had one idea for what to try, really. Nothing meaningful, at least. Like, put a negative number for the number of entries doesn't really do anything. You know, it's a wild guess, and I didn't think it was going to work in the first place. I don't know quite why it is working to the extent that it is. I guess it must just be that this is a signed comparison. And, well, okay. So if it's a signed comparison, because otherwise it's going to be greater than, and we'll come down here. So explicitly right, let's look at the sub instruction. What flags is it going to set? I don't still have it open. Why we not? That's just what is considered the operation. Doesn't mention how the flags are set. Okay. Let's do like ZF. Maybe appendix A. What is sub? Look at compare with EAX and an immediate single byte. Or I guess it'll be this one. So it'll be 3D. That one, I don't know. This is not the table that I want to look at, I think. Oh, Jesus Christ. Here we go. Too much. So it's going to set OF, SF, ZF, AF, PF, and CF. OF, sign flag. Okay, ZF, parity and carry. And AF, auxiliary carry. So then we're looking for JLE. Okay, so if the zero flag is 1 or the sign flag does not equal the overflow flag. Interesting. So as long as we didn't underflow, basically, and our result is negative, I guess that makes sense. Or 0. Okay. So then, if 21C is negative, this is going to be the same scenario, then we will keep looping. Or you'd think that we would keep looping. Oh, sorry. That's if 0 is less than whatever our number is. So if we ever put in a negative number, right, that's why we didn't get any prompts, then this negative is just going to take us down the output path. And maybe the find would break. Maybe. Because we are passing in a negative number there. But, I mean, again, I put in a negative number, and we can try fuzzing it, right? Let's do a lot. Yes. Can we reduce some of the spam? Just wanted to not print something every time I spawn a process. But doesn't seem like we have that option. Unless the context allows us to say like quiet. Verbose. Alright, let's do that. So the idea is we will loop through from -1 to -2000. If we ever get an entry that doesn't just print out results and exit, then we'll be sitting on this receive all and we will have printed out trying. So we know what that input is. What? Is that not? Oh, maybe I just call quiet. No? What? Jesus Christ. So local context. Just as a width. Okay. Like that. Gonna actually. Nope. So, I mean, could be later than that. Oh, hey, I didn't see people were talking. Doxbic. Yeah, I'm using Radar for reversing the little CTF binaries that I'm working on for opponables challenges. And Proots, good evening to you too. Yeah, you've caught me at a time when I am working on a challenge that I have no clue at this point what I am supposed to be doing. I mean, I have some vague concept of what I thought I was supposed to be doing, just based on the fact that I'm in a challenge that's in the array indexing category, but I didn't find anything. I haven't read through the walkthrough at all yet. I haven't yet decided that I really like. I'm moments away from deciding to start reading the walkthrough because I can't think of anything. But my assumption with an array indexing kind of challenge is that you can do some kind of out of bounds write. So you can write to memory that you shouldn't have because of indexing, bounds checking issues. And reviewing the code for this stuff, I didn't find anything to indicate that was a possibility, basically. So I'm at a loss as to how to go about this. Yeah, I guess I'm gonna look at the walkthrough because I can't think of anything else to do. I mean, they immediately leak you a stack address. That's handy, but only if you can write something somewhere. Then prompt for a number of entries. You can give values for those entries. It will calculate a sum, find the minimum maximum values, pick one that it likes. It seems to be like picking a number between -10 and -100 is what I got from reversing the code for this function. Or it will pick the first one in the entries if it didn't find one of those. Then it will sort them for you. Okay. You know, I didn't actually look at the sort function. So, I mean, maybe there's a out of bounds from that. It seems like it would be tedious to review, but it's not a lot of code. Okay. So, like the other ones, the sort function is taking, first parameter is the number of entries, second parameter is the array of entries. What? GS sort. Okay. So, let's see, we've got local 10 is 0. This is going to get the number of entries in there, and we're going to compare against that, starting at 0. If it's less, then we'll go in. Otherwise, we're done with the loop, I guess. I'm going to return 1. So it looks like maybe a bubble sort, because we start at index 1, and for each one of those we have a nested loop, which starts at index 0 rather, and then for each index from 0 through the end of our array, we start at index 0 for an inner loop, which I'm guessing will iterate through each entry. So we get, hey Julian. Yeah, I mean, I got started pretty late today, so I've only been going for like an hour and 40 minutes. I'm gonna try to solve this one, but probably I'm gonna need the walkthrough. So you can still hang around and watch me work on this one, or I don't know if you're still here. Okay. So local C, what do we have in local C? Oh, right. Local C is the inner, okay, inner loop index value. Let's call it J maybe. And right, so we load that to EAX or wherever. Right, we load that onto the floating point stack. Whatever double is at that index in the array. And then add 1. Yeah. So if there's any entry that is greater than the one that comes after it, then we will swap them, I guess. This one is a array indexing pwnable. It's the first one in this section, but it's definitely confusing the hell out of me what I'm supposed to do. My guess is have to figure out how to get it to write something that it shouldn't write. Like, I don't understand how I can pwn something if I can't, at this point at least, with all the things that I've done so far, all of my solutions to be able to solve a pwnable challenge involve some kind of memory corruption. And I would have thought, unless it's like purely, hey, we've loaded the data into memory and you just need to leak that particular data. But if you need to open a separate file or something, you need code execution to achieve that. So this one doesn't seem to have loaded anything. I don't know if there's even a flag file. I think you're just supposed to get code execution, and I don't understand how I can do that without writing memory somewhere to influence the execution behavior of the program. And I have yet to find where it is possible in the program to write memory that shouldn't be written. But I also do not know if I don't know if that's really what I'm supposed to do in this. It's the only thing I can think of to do, and certainly it seems like a possible thing to do when you have a NX is not enabled, so we could write data that goes into the buffer on the stack, but we can't overflow the buffer. And there's a stack canary, but there's a success, like, we can only write 64 doubles into that thing, and if we say we want to write 65, it just goes no. It does leak us the address of the system function, but I think that's just trolling. I don't think, because I mean the program exits immediately after that, and if we haven't written any data to impact that, then having access to it, since it's a different address every time, I'm pretty sure. Oh, sorry, I didn't mean negative 65. Yeah, right. It's like with ASLR, it's going to be at a different address every time. So the fact that NX is disabled, I don't think helps us in this scenario. And really what it does, if we run the program and we say like 3, give, whatever numbers we want, and then it will print them for us, it'll add them up, give us the min and max of those, it'll pick one of them and sort them. And I'm looking at the sorting code right now. It's a pretty straightforward bubble sort, I think. It's an O(n) squared kind of solution for sorting. And what do we do? I'm just trying to double check that there's like not anything broken in this implementation, but I haven't seen anything so far. Okay. Yeah, now, I'm very curious what is intended on this one. Because it doesn't actually prevent you from putting in a negative value, but it's not going to accept any inputs because the loop check says like, hey, is the number of inputs or is 0 less than the number of inputs? 0 being whatever our counter that we're keeping track of is. and it'll just quit out on the first one, the first check. So yeah, let me double check like what I thought. Yeah, it does like the whatever this like find a number is, it just finds the first number that's less than -10 and greater than -100. Okay, so back to the walkthrough. Yeah, we get the stack parameter leaked, or stack address leaked rather. It's the beginning of that array that we're writing to. So if we could overflow it, if I can think of a way to overflow it, and then, or not necessarily overflow it, but really write out of bounds to write to the return address, then that's a much more straightforward solution. Because we can put our shellcode, we encode it as doubles or whatever, enter it in. We have already leaked the beginning of where our shellcode will go. And but what am I not seeing in this bit of code? What do I do in here? EBX -8? EBX is our like pointer to use for position independent references, or just generally relative references. That's like we're using this to do a relative reference to get a string at a fixed address. Even though it's listed as no PIE here, it's basically been compiled as position independent code, so I don't know on that front, but we're doing EBP -8, and that is, oh, that's probably like, this is us getting the file pointer for fgets. So read in 100 bytes from standard in. Okay. see anything. All right. So let's see if there's anything more obvious in the C code, maybe? Link the array to the pointer. Put pointer array, but it's really the double array. Oh, I guess it's maybe a pointer to the array. Sure. Scan in to. I don't know why they've named these how they have, because I think these names were set by the person writing the walkthrough or the write up as they were annotating. Because I mean, I doubt that these names would be guessed by Gidra. So scan in the number, it's greater than 64, print that out. Sure. Then, well, that right, 64 entries in the double. A to F. Maybe that's the issue. It's the same instruction opcode whether you're using a float or a double, though. So it's not clear to me. It's not clear that there is yeah, and it returns a double. Okay. So it's not a type issue with that. Oh yeah, -100. Okay. I guess there's a possibility, since we are passing in a reference to the number, and I know that the favorite thing writes to that. It's implemented in a kind of a weird way, or not the favorite, but the find array function is implemented in kind of a weird way, and it does write to that address rather than just read it, which is really weird. It shouldn't need to modify the length of the number of entries at all. But it's possible that as a result, when we call sort array, it messes something up. I didn't see any place that looked like it would be writing the wrong stuff to the size. Why did it not go anywhere? Okay. So we're gonna put local 4, which is the size, into there. Local, wow. Okay, that's cool. No, don't want that one. Well, now, okay. What's going on here? But this is before we loop back. What happens when we get out? Maybe. Okay. So, right here, we are writing to the memory from the calling function where it's storing the number of entries. So rgate is the address of that D word for the number of entries. Put that address into EAX, and then we write to it with the move instruction with EDX, which is the number of entries, whatever we currently had, plus 1. So this is us just incrementing, but we are incrementing starting from the actual number of entries, because again, this function is written kind of weirdly. So if we had 10 entries, this value starts at 10 and it's going to count to 20. And then what we're supposed to do is end up returning the right index in EAX, because we will subtract, local 4 has the original length in it. So we would subtract 10 from whatever number we got and have that in EAX, and that would work. But we've already modified the length. So maybe if it finds an entry that fits, so it'll go through a couple times, it will not find entries that it wants, and then when it does find one that it wants, it's done, but it will not have written back the correct information, the correct length to rgate. So then we will sort more than we should have, and maybe we just need that entry to be, this would be so annoying, I think. Let's do 10. Did it do anything weird? I mean, we definitely got entries in the sorted array that were not entries that we put in. Right? So of course, I don't know if we can properly interpret these, but that's not the point. So the sort is going to sort stuff that it shouldn't. So let's do we want to fuzz it. Let's see if we can get one crash, and then I might be able to fuzz it and figure out how to print out a relatively short printout of all the crashes that we can get. So let's do 64 entries. We might have to do the full size to get stuff to break and like mess up the stack canary. Yeah, because we'd have to do at least 32 entries, I think. Let's try that. So we do Python. I'll do it on the last one, I guess. Did that. Didn't seem to break anything interesting. You need to do more than that. Let's try the full size thing. Okay, so that was able to overwrite the stack canary, break it. About 48. Also, okay, so I need to believe in myself more that I can figure stuff out. My brain is rebelling, just not wanting to think about how to make this work. So if we put in an entry oh right, so it should be like 33 should be enough to do the stack canary, right? Okay, so if we do 33 entries and the last one is the one that it's searching for in this find array function, because of the weird way that it's coded, the number of entries will come out as 64 plus, or 33 entries plus 32, and those 32 additional entries let's see. Is it accurate? I think so. And so then when it sorts it, it's going to sort 65 entries. And sorting. But we need like. We have to both make sure that the stack canary doesn't get moved from wherever it's at, which is tough because it's random. And we're working with doubles. God damn it. How is this the first entry in this section? This one is fucking. This challenge is over. Yeah, I mean, it was tough even just coming. I had to force myself to look at code again a couple of times just to be able to discover the mechanism that's triggering sort of overflow or out of bounds access, I guess is the better way to state it. Let alone how to now take advantage of that, given the fact that we are doing double based encoding. We have a stack canary that's in the middle of this, and the modification mechanism is sorting data that is not necessarily doubles and stuff. And so there are a number of layers to how to get this to work that just seem so annoying to implement. Annoying even to come up with. I mean, maybe not that annoying to implement, but annoying to come up with what the implementation needs to be. The thinking part seems like it's. Might have to write some stuff down. Fuck. I also don't know why the stack canary is being modified when this happens, because what are all these values that we like? Moving around. Right, we're putting in 0 for everything except for the negative 15. So let me go ahead and just going to try this in GDB. So do I think that's no and then double check that works. What is the sure. No, I don't need len. Okay. So what do we want to do here? I just want to pause after we open it, I guess. So I want to see what is on the stack, basically, when we start sorting stuff. Because we're getting a lot of values, all of this stuff up here, that are not the zeros that we provided. Oh, it is going to be garbage. Okay. That's where it's probably coming from. So we're not like clearing out the buffer on the stack where we're storing all of these doubles. So we'll have our 30, roughly, what, 32 zeros in there. I have no idea how we got a zero up here. Like, some of these are not sorted, it seems like. Yeah, that's real weird. The sorting seems broken in some manner or other. Okay, so other than the zeros, though, it's other stuff that would be in that buffer space that was never written to, and so had whatever was on the stack from before. And because with 33, I'm pretty sure the highest, the like furthest value that we will reach in the sorting function is just the stack canary itself. So like none of these are pieces of data beyond the stack canary, but we don't know what the stack canary value is, so it's going to be sorted in an unknown place relative to where it was. And again, the like we're working with 8-byte values, and our canary is 4 bytes. So we have to consider what is the data that is put after that canary when treating it as a double. And then same goes for the return address. So deeply just tedious is what I would call this challenge. But, you know, I don't know if I should be so complaining so much. No, I want game function. So right before we call sort 557. Continue. We get to the sort, and now is there a good way to look at the stack? What do we have? Yeah, so 65 is the what am I saying? Is the number of entries that we're going to try to sort, which is conveniently one more than our the size of our array can fit, and the canary is immediately after that, I think. Probably listed up here. So we put it at EBP minus 4C and 210. Yeah. So it's immediately after. There is other stuff. I think we've pushed a couple of registers that come after the canary. So let's look at one word at, so that's our canary. If we look at it as a giant, no, not GW, 1G, this is the value we get. It's probably, this is probably consistent then. So that might help. Probably not, because the upper bytes are the ones that are going to be randomized. So the upper bytes, or let's do it this way. So import struct. We'll do our like conversion stuff in Python, I guess. Unpack float 20.64 bit from bytes. It's going to be struct.unpack. Lower, lesser, what, little endian. And then that's a double B0, I think. So then if we pass in okay. And if we have 47 here instead, all right, that doesn't change it very much. If we have B here. Okay, that's good to know. This is a 9 instead. So, okay. So I guess, yeah, these are still the high valued bytes, obviously, because we're reading it as little endian. And so this stuff will be like in the mantissa as lower and lower valued bytes. So regardless of what the canary is, like I think if we run it again, just do it in GDB directly. Set that breakpoint and run it. What? Did we not hit the... Oh, because we aren't doing... Okay, I don't need the breakpoint there, actually. No. We can just put it up at the beginning after we move in. Set that. So 31. And run it. And then so if we have 7E, 05, 0B. I think that's it. Okay. Oh, and it's still gonna be 8. Yeah, so we know that 4.90966 to the negative 270, or 10 times 10 to the negative 270 is going to be our stack canary. And so we need to ensure that all 64 entries that we actually provide are smaller than that value, and then somehow ensure that the return value, actually not all, and it's got to have our stack code. I don't, oh Jesus Christ, or our shell code rather. Not all have to be less than that. At least one of them has to be high enough that it gets replaced with the return value. So if we look at, let's look at it as a giant again. So that's the next two things on the stack. And then, yeah, so this will be the number that comes after, and then this will be the number that comes before it. And I do pack 64. It's an AN. Yep. Not very helpful then. Because I don't know where that'll get sorted to. So we do 34 entries. Let's do 64 entries. We want to we've got a lot of entries that are going to be smaller than our canary, which is this one. Okay, so the canary is at 124 on this execution. It is at 123 on this one. $124. 23. Sort of maybe a matter of. Oops. But we aren't seeing Nan, which is interesting, because maybe I am misinterpreting that. Say float, maybe. No, it is. Yeah. So, I guess I'm a little surprised that there are no entries that count as Nan. Oh, they are sorted properly. I think I was confused earlier by the sorting because these are the negative ones, which are very large negative numbers, but then we have a whole bunch of very small positive numbers. So, in theory, we need to get rid of 60 entries. I don't. Alright, I think what I'm going to do for this session, so I'm feeling maybe a bit demoralized with how much work this is going to be. I don't know. Do I want to. I was thinking to read through the walkthrough just to confirm what my plan was correct. Because the more that I think about this, the more difficult it's going to be. It feels like. And I thought it was going to be really difficult as soon as I realized what I thought we needed to do. But if our stack canary ends up here after the sorting, and we need it to end up here, or I guess here because it's 0 based. Yeah. We need to have at least this many entries, or at least this many that are larger than it, which is nearly every entry that we could give. And if we are using all of those entries to provide something that is larger, we have to have some of them also be our shellcode, I think. Because then we have, that's like 60 entries or so out of 64. So let's say it's 60. Then we have 32 bytes of shellcode that we have to keep in order after the sorting. And we'll have to know where it's going to show up in the sorted result. unless we can do a NOP chain. Or NOP sled rather. So we did so that's a very small negative number. I don't know. So if we're doing this, let's say we just have 0. What does that look like? So that's pretty much the same. The canary is probably not going to be all zeros, but that's our best bet for making it smaller, I think. I think if we add 1, yeah, then it gets a little bit larger. So, okay. So let's say we use this as our number. How do we convert that? Python. Oh, just float? Okay. So we get that. And I want to do Python float to bytes. Maybe it's in struct. We want to struct dot pack the float, right? Okay. Okay, cool. So let's say that's the number we're going to put in. Actually copy it into clipboard or just... What does it look like? Okay. Then we're still got too many, obviously. So we'll do like how many can we do? We have 55 numbers. No, yeah. We have 55 numbers that are too small. So really we just need or 56 rather. So we need 18 or sorry, 8 to get to 64. My goal right now is just to get the stack canary to stay in place. So we need 8. And then we can just do 1. Let's say that'll get sorted to the end. Okay, so that actually worked. We have obviously overflowed. Did we overflow? No. Why didn't we overflow? Or, you know, sort out of bounds. We provide 8 entries. We say that we're going to do 64. Oh, because we didn't provide the negative number to trigger the problem. Still smashing the stack. Okay. But our canary is at 69. Is this going to be just random? It's at 70 that time. Okay. So it does seem to, you know, have like a 50% chance. Just need 3. So we need it to be at 63. Do 2. Start with that. Okay, right now it is at 62. Interesting. It's 66 now. I mean, yeah, there's definitely a certain amount of randomness in this. So I'm gonna put 2 in because I think still never working. It's at 63. So it has been sorted to where it should be sorted. I thought. All right, let's run it. I mean, yeah. So if it's at 63, let's run it in GDB, I guess. Five, 5, 7. Okay. Continue. All right, then let's look at the canary. Okay. And then we will step over. And now the canary is that one. Interesting. Okay, it got sorted one too early. What was the value that came after it? Or that was in its place? Said it was 6 to the negative 316, but that showed up, didn't show up anywhere. Is it not on? Should be on a like boundary for the double. I mean, I'm pretty sure it's this one. Oh no, that's 670. Maybe I am misunderstanding. I thought that was going to be the canary value. Oh, but like it got. Maybe I messed up on printing that. C through F, it's only 4. Let's try it again. All right, let's look at where the canary is. This is our canary, B6 1C5400, or 0B61, yeah. Okay, then step. That's a different one that's been put in there. Fair enough. Oh, well, okay. That's gonna make it hard. I don't know why I was. Look at this. It's a float. I don't know. It's too many layers of bullshit for me right now, I think. So I'm going to end the stream for now. Come back and I still think the first immediate goal should be provide entries that make sure that the stack canary gets sorted into the original, it's the same address that it was at before. And then, once we have that locked down, we can look at what our options are for placing stuff before or after the canary, and then lastly getting the return pointer where it needs to point to, and getting the shellcode encoded so that it goes to, it sorts properly and doesn't mess up the requirements that we have around sorting and making sure the stack canary is where it's at. The shellcode itself stays in the same order. All of that stuff, like, it just, I can't believe this is the challenge. Who would do this? Who would make this challenge? Well, that's where we're at. So I do wonder if any of the other ones are like a more sane problem. I'm not going to look at the details, although anything from DEF CON qualifiers in the previous challenge section was pretty difficult. So, yeah. Maybe it just gets more difficult from here. Fuck. Okay, well, that's where I'm going to end the stream for now. Thank you all for everybody that showed up and got to watch me struggle with this. I'll come back tomorrow. We'll do some more. Maybe I'll be in a better mood about it tomorrow.